Gusto niyo bang sagutan natin yung quiz nyo or yung kwan na lang, yung topic na lang na i-discuss ko? Pero since nakita ko naman dun sa mga sinubmit yung quiz, halos lahat naman kayo na nakuha lahat ng mga sagot. Anong mas prefer nyo? Discuss natin yung solution ng bawat item dun sa quiz nyo or proceed na tayo dun sa main topic natin? Hello, or baka may mga nagmamadali dyan? Wala naman? Ay, okay. Sige, sige. Since thank you for the comment na yun nga din kasi nasingit lang natin ng yun nga Sunday baka mamaya may mga Sunday service kayo or may mga family gatherings. Hindi naman natin naiwasan. Okay, sige. Yung sa main topic na lang muna tayo. The following meeting na lang yung isang topic which is yun na kasi yung pinakamahabang topic kaya dapat i-discuss ko na halos present kayong lahat or halos karamihan sa inyo is present. Okay, proceed na tayo sa topic for today. I-discuss ko lang yung sa number 7, yun yung topic na gusto kong i-discuss ngayon kasi hindi ko na-discuss sa inyo nung nakaraan. Which is, pero kung naman bigyan, related dun sa mga previous topics natin, lang yan, it's a continuity equation kasi malalaman natin yung mamaya. Ito yung number 7 dun sa quiz nyo na binigay ko. Water travels in a hose with a speed of 0.8 meters per second. The cross-sectional area of the exit nozzle is 1/5 that of the hose. At what speed does water exit the hose? So ang given lang sa problem na to is yung velocity which is 0.8 meters per second. And yung cross-sectional area, wala siyang binigay na exact na area na nagkaroon pa siya ng another tricky questions which is yung 1/5 that of the hose. Which yung sa hose tapos may nozzle pa siya. Doon sa nozzle, yung 1/5 nung area nung hose. And this problem is about continuity equation. Let's discuss about continuity equation. When a fluid is in motion, it must move in such a way that mass is conserved. To see how mass conservation places restriction on the velocity field, consider the steady flow. Yung magiging flow ng tubig natin is steady lang siya. Parang tinagalog ko lang din. Of fluid through a duct, that is, the inlet and outlet flow do not vary with time. Kung ano yung inlet na, kung ano yung pumapasok, yun din yung nilalabas niya. Yun yung gusto nyo sabihin ng yung nakaparanthesis. Inflow and outflow are one-dimensional. So that yung the velocity and density are constant. Since yung fluid na nag-travel dun sa pipe na yon is the same fluid, kaya nagiging constant yung density over the area. Fluid flow is the volume of fluid that moves past a certain point per unit time. So, ang magiging, kung natatandaan nyo yung formula natin ng volume flow rate, which is yung discharge is equal to volume over time. And i-expand pa natin yung mga covered ng discharge or the volume flow rate. Considering ito yung hose natin and ito yung nozzle portion, kumuha tayo ng a certain amount or a certain volume. Ito yung cross-sectional area ng hose, yun nga, hose naman is alam naman natin na karamihan is yung bilog yung kanya. Wala pa naman tayong na-encounter na hose na may iba-ibang shapes. And yung cross-sectional area, para makuha natin yung volume, kung kuha tayo ng a certain length and yung area times a certain length is equal to volume. Tama? So, balik tayo dun sa original formula na Q is equal to volume over time. Kung i-breakdown natin para makuha yung volume, kailangan natin yung cross-sectional area times yung length para makuha natin yung volume. In-expand lang natin. Times I over time. And yun nga, kung matatandaan nyo to, yung unit ng velocity is meters per second. Yung as the water flows at a certain period of time, ito yung magiging katumbas niya. Kung kumbaga nandito siya at 1 second and at 2 second nandito naman siya, 3 second andito yung water and at another seconds nasa other portion na siya. Yun yung big sabihin ng kaya natin break down yung L1 over T. So ang magiging formula natin sa equation na to is we will derive the equation of Q1 is equal to A1 times velocity 1. Naintindihan ba? Or kailangan ko bang i-explain ng maayos? So, parang okay naman ata, walang comment. Wherein, yung Q natin is the volume flow rate or yung discharge. And V is the volume and T is the time. And yung A is the cross-sectional area and L is the length and V is the velocity. Okay, let's proceed to the other portion, other part kung bakit natin tinawag siyang continuity equation. Dun sa yung volume na nasa A1 is kailangan natin hanapin yung katumbas niya na volume sa point 2. Since mas lumiit yung cross-sectional area at point 2, ibig sabihin mas lalapad yung length nung at point 2. And yung magiging discharge at point 2 is maging same din sila na area at point 2 times V2. Ang magiging consideration lang natin dito, yung volume na kinuha natin dito, mas kailangan natin hanapin yung katumbas na volume along sa point 2. Therefore, the volume flow rate at section 1, yun nga sinasabi ko sa inyo, must be equal to the volume flow rate at section 2. So, the Q1 is equal to Q2. Yung discharge na at point 1 must be equal to the discharge at point 2. So, doon sa quiz na binigay sa inyo, water travels in a hose with a speed of 0.8 meters per second. The cross-sectional area of the exit nozzle is 1/5 that of the hose. At what speed does water exit the hose? So, sa Q1, we will use the equation na na-derive natin, which is yung A1V1 is equal to the A2V2. Yung A is the cross-sectional area and yung A1, yun yung magiging isang basis natin. And yung velocity, which is 0.8 meters per second. And yung consideration natin dun sa exit nozzle is 1/5 siya ng A1, yung cross-sectional area at point 1, times yung velocity 2, which is yun yung speed ng exit nozzle. Ay, speed at exit nozzle. So, substituting the equation, A1 times 0.8 meters per second, transpose lang natin, and over 1/5 of A1. Kung bakit hindi natin kinuha uh, yung cross-section at A1. Kasi kahit hindi given dun sa equation, considering na may katumbas siya, which is 1/5 of the host or 1/5 of the cross-sectional area at host, doon na sa pinag-transposean natin, may maka-cancel out lang din yung A1 over A1. So, ang matitira na lang na equation is yung 0.8 meters per second over 1/5. And we get the answer per unit volume. I-expand natin dito yung discussion kung saan nakuha itong 1/2 rho sphere. And the last one is the hydrostatic pressure, which is defined, which is represented by rho GH. Where rho is the density, G is the gravitational acceleration, and H is the height or elevation of the fluid with respect to reference line or datum line. H or sa ibang term kasi ginagamit nilang symbol is Z. Pero yun pa din naman yung ibig sabihin nun. Yun yung difference in elevation with reference to with respect to reference line or yung datum line. It can also be written in different forms. So, yung main form niya, yung pressure form. And ito naman yung energy form niya. Kung mapapansin nyo, ito yung pupuntahan niya na pag-solve ng problem is nakadepende lang kung may mga what do you call this one? May mga specific na panggagamitan lang itong mga different forms na to sa mga ganitong problem. And this is the head form. Sapita ko lang niya yung ibang mga variables. Pero lahat yan ay napupunta dun sa may kanya-kanya silang respective variable na derive yung mga formula na yan. Okay, let's yung mga relationships between these formulas kung bakit sabi ko pag ginamit sa isang problem yung makukuha. We can see that Bernoulli's equation as a statement of conservation of energy. Along with the sum of yung unang P, which is the pressure energy, plus yung energy, which is one of rho v square, plus yung potential energy na rho GH is a conservation of energy. That sila is classified as energy and equal to constant. Okay, derive natin para makita nyo yung maging mga relationship ng mga pinakita kong formula from pressure to energy to head form. Okay, dun sa discuss ko kahapon, last meeting, yung about dun sa discharge inlet is equal to the discharge nung ilalabas dun sa pipe. And the assumption natin is ideal fluid siya, yung normal na fluid lang na incompressible and steady flow and no internal friction. Saka na lang muna natin yung pag-usapan yung about the internal friction. Kasi kung step by step na lang muna tayo. Dun sa internal friction kasi nandun yung mga rust dun sa loob ng pipe, yung mga pumipigil dun sa velocity ng along the pipe, yung height niya, yung mga rust or yung mga frictions. So, ang isipin na lang muna natin is no internal friction. Smooth pa lang yung flow ng tubig or fluid natin. And the density is constant since isang fluid lang yung dadaloy sa pipe. So,
last meeting we discussed about the discharge and how we derive the discharge. And yung discharge is equals to volume over time. Kaya nga tinawag siyang volume flow rate. And kung paano na-derive yung na-i-break yung volume is ito yan. Yung area times yung length over time. And yung area times yung parenthesis L over T, which is yung length over time is equal to the velocity. And we derive the equation Q is equal to A times V. So, we can clearly say na yung discharge na papasok dun sa pipe natin is equal to dun sa discharge na ilalabas dun sa mismong pipe din. So, Q1 is equal to Q2. Let's say Q in is 1 and Q out is 2 na lang. And i-expand natin yung formula. Yun nga, yung A1 times yung velocity 1 is equal to A2 times velocity 2. Ito yung isipin nyo din guys, when the area decreases, the velocity increases and vice versa. Kung mapapansin nyo, habang lumiliit yung area, cross-sectional area ng pipe, bumibilis yung velocity niya, di ba? At habang lumalaki din, bumabagal din yung velocity niya. When the fluid is speed up, it means that there is an acceleration happening in the fluid. Yun yung relationship niya. Kapag lumiit yung pipe, i-increase yung velocity niya. Which means na may acceleration na nagaganap dun sa fluid. And acceleration has to be caused by some force. The only way to determine the force is to determine the difference in pressure. Kung naalala nyo, yung formula ng pressure is equal to force times area. So, may force na nag-act dun sa fluid. So, there is an acceleration. There is a result of acceleration. And there is a difference in pressure between the large pipe and small pipe. Since there is a difference in pressure that causes the force to be exerted in the fluid, which means work is being done in the fluid. When work is done in an object or system, it can cause the kinetic energy or potential energy of the object system to change. Dito na pumapasok yung potential energy and kinetic energy at potential energy at kinetic energy. And itong kinetic energy is nagbabalance lang tong dalawa. Yung nilolos ng kinetic energy, yun yung ginigain ng potential energy. Habang yung nilolos din ng potential energy is yung ginigain din ng kinetic energy. Since work's done, we will use the equation work W is equal to the change in kinetic energy plus the change in potential energy. Okay, so far naintindihan naman?
Yes, sir.
Okay, let's proceed. Let's consider this equation. Pressure 1 and the cross-sectional area is 1 and yung velocity. Ganun din yung sa kabila. I will discuss later kung ba't iba yung direction niya dito sa pressure. May velocity din siya at may change in x squared. Kung paano natin nakuha to is yung sabi ko kanina, yung discharge kanina, yung volume na pumapasok sa point 1 is kukunin din natin yung katumbas ng volume na ilalabas niya dito sa point 2. So, work total is equal to work at point 1 plus work at point 2. So, we will expand the equation. Since the work done by P1 must be the force that P1 exert on the fluid multiplied by the distance in which the force is exerted. Kung bakit naging negative yung pressure at point 2, ito na kasi yung magiging result niya due to dun sa change in height niya. Since pataas yung pipe natin, magkakaroon siya ng parang another pressure na magtutulak din dun sa pipe which magpipigil dun sa pagbilis din nung velocity. Pero yung velocity pa din, when she reach this point is mas malaki pa din compared to the velocity at point 1. And ito yung sinasabi ko kanina regarding dun sa reference line or datum line. You can consider this reference line, yung dito sa baba niya, which is the H1. And yung magiging another height niya is yung H2. Kung napapansin nyo, kinuha natin yung reference line sa middle ng cross-section. And ganun din yung mangyayari dun sa point 2. Kukunin din natin yung reference line niya dito sa middle din ng cross-sectional area. Pero pwede din naman kunin dito sa pinakababa kung dito mo gustong ilagay yung reference line mo. And still yung ganun din yung mangyayari at point 2, dito mo din sa baba niya kukunin yung magiging end ng reference line mo. Okay, let's continue. The formula of kinetic energy is AE is equal to 1/2 mv square. So, kung napapansin nyo yung kung naalala nyo yung formula natin dun sa density. Density is equal to mass over volume, di ba? We will isa-substitute lang natin yung mass into a fluid form kasi hindi din natin makukuha yung mismong hindi siya solid na object. This is a fluid, so we will substitute the mass as rho v. Naalala niyo pa ba yung formula natin ng density? Rho is equal to mass over volume. So, kung i-transfer natin yung kung i-derive natin yung M, ito yung magiging kalabasan niya, rho v. Since ito nga, change in kinetic energy, V2 square minus yung V1 square. Then, let's proceed to the gravitational potential energy. Ito yung formula ng potential energy. Potential energy is equal to mass times gravitational acceleration due to gravity times h, or z yun guys. Pero I will just use the letter s, h as yung variable natin sa height. So, ganun din yung mangyayari. Kukunin din natin yung katumbas nito dun sa fluid. And ang katumbas nito is yung rho times yung volume niya. So, the change in potential energy is equal to rho v times g less the quantity of H2 less the difference of H2 less H1. Dun nga kanina, since may reference line tayo, makukuha natin yung change in height dun sa pipe. So, substituting the equations that we derive, since W, yung katumbas ng W kanina is P1 times the cross-sectional area times the delta x, yun yung distance ng volume kanina, less yung P2, H2 less delta x2 is equal to yung formula ng change in kinetic energy, this one, plus yung formula ng potential energy. Let's expand further yung paano na-derive. Since wait lang guys. Since ito since A1 times yung delta x is katumbas niya is volume, and A2 times delta x2 is katumbas niya is volume pa din. So we will substitute this equation into P1 times volume plus P2 times volume para mapaliit natin yung equation. And ganun din yung since wala namang changes dito sa kabila. And as you can see, may common variable silang lahat. Kung nakikita nyo, lahat sila may common variable na V, which is the volume. So, we can, since all terms have a common variable which is V, the volume, ang magiging i-divide na lang natin silang lahat ng volume and para ma-cancel out yung volume. Since yung volume na tinutukoy dito sa kabila is yung same din sa volume na tinutukoy dito sa right side, we can cancel out the volume and we can mas mapalit pa yung magiging formula natin. And we will get the formula pressure 1 less pressure 2 is equal to 1 half rho times the difference between V2 square less V1 square plus the rho G times the quantity of times the difference of H2 less H1. So, ang gagawin lang natin is pagsasama-samahin lang natin yung mga magkaka-same ng symbol. Yung mga positive ilalagay natin dito sa left side, yung mga negative ilalagay natin dito sa right side para ma-derive natin yung formula. Since negative yung P2, pwede na itatransport natin siya dito sa kabila para mag-positive siya. And since negative din yung V1, we will transpose yung V1 dito sa kabila para mag-positive siya. And same here as height 1, transpose na rin siya dito sa kabila para mag-positive siya. And we will derive the equation P1 plus 1 half rho V1 square plus rho GH1 is equal to P2 plus 1 half rho V2 square plus rho GH2. And ito yung Bernoulli's energy equation in fluid flow. Dito na-derive yung pinakita ko kanina na Bernoulli's equation. Naintindihan ba kung paano na-derive yung Bernoulli's energy equation and kung paano na-arrive sa formula? Or may questions kayo?
Hindi din.
May magaling lang basara. How about others? Naintindihan ba? Okay, let's proceed. Example problem tayo. Water is flowing at a rate of 2 meter cube per second. Application pala tayo guys. Water is flowing at a rate of 2 meter cube per second through a tube with a diameter of 1 meter. If the pressure at this point is 80 kPa or kilopascal, what is the pressure of the water after the tube narrows to a diameter of 0.5 meters? So, ang given is yung pressure at point 1, dun sa may diameter na 1 meter is 80 kilopascal. And with a diameter of 1 meter. And yung the water is flowing at a rate of 2 meter cube per second, yun yung discharge niya. So, Q is equal to 2 meter cube per second. And the diameter at nung nagnarrow na yung tube is nag-decrease nag-decrease siya into 0.5 meters. Ang tinatanong is what is the pressure of water after the tube narrows to a diameter of 0.5 meters? Okay, let's take this figure. Sa portion na to, nandito yung diameter na 1 meter and nandito yung 80 kilopascal na pressure. And yung hinanap natin is yung dito na portion na after the tube narrows to a diameter of 0.5 meters. Sabi niya kasi, basically, mga nandito na portion yon na part. And using the equation, P1, yung na-derive natin na equation, na Bernoulli's equation, plus 1 half rho V1 square plus rho GH1 equal to P2 plus 1 half rho V2 square plus rho GH square. Kung napapansin nyo dito sa figure natin, yung pipe is walang change in height. Ang pipe lang natin is diretso lang siya. So, we will cancel out the part which the H is present. And formula natin, ang H is present siya dito sa potential energy. So we can cancel out this part, the formula with the H. So ang matitirang formula lang natin is yung P1 plus yung formula ng kinetic energy. And substituting the equation of P2, itatranspose lang natin siya since P2 yung hinahanap natin. P1 plus 1 half rho P2 square plus D1 square. So, ito na yung magiging formula natin. Ang kailangan natin hanapin is yung B2 and yung D1. And given yung discharge, and alam naman natin na discuss naman natin kanina na discharge is equal to times velocity. And we can derive the velocity since given naman yung diameter ng pipe. So, Q is equal to EV and velocity is equal to Q over A, or pwede nyo na lang i-shift mo lang sa calculator. Pero ito yung magiging kalabasan ng formula. V is equal to Q over A. We just divide the area para both sides para makansal yung area dito sa both sides. And mag-transfer yung area dito sa baba ng discharge. So, we derive the equation V is equal to Q over A. So, given naman yung diameter, so we'll kabisado nyo naman yung formula ng area of a circle. Itong area of a circle, pi d square over 4, or kung yung radius naman yung given, you can use pi r square. And since A1 is velocity na pala ito, hindi pa, A1 pa lang niya. Dinederive pa lang pala natin siya dito. Ang A1, substituting this equation is equal to 0.7854 meters square. While A2, substituting this to this equation, we will get the area of 0.1963 meters square. And since nakakuha na natin kanina kung paano kunin yung velocity, we'll just substitute the discharge dun sa B1 mo lang tayo, 2 times yung nakuha nating cross-sectional area at 0.1 over 0.7854, and we will get the velocity 2.5465 meters per second. Sa B2 naman, substituting this to formula, 2 over 0.1963 B2 is 10.1859 meters per second. Ba guys, or masyado mabilis yung pagkasabi ko? Hello? Questions? So, di ba nasunod naman siguro? Nag-substitute lang tayo ng formula sa mga na-derive nating equations kanina. Since meron na tayong V1 at V2, pwede natin siyang substitute dun sa main formula natin na P2 is equal to P1 plus 1 half rho at the difference V2 square plus V1 square. Kasi na-derive na natin yung V2 at V1, we will just substitute it to the main formula. Since yung 80 kPa yung given, and yung mga nakukuha natin na unit is nasa mga meters per second sa meters square. So, 80 kPa is to convert it into Pascal, just multiply 1,000 times plus 1 half, and yung density natin is given na fluid is water, which is density is equal to 1,000 kilogram per meter cube times the density of yung given 10.80 yung square ng velocity plus yung v1 and we will get the answer p2 is to 128.66339 kPa. In-adjust ko na yung sa ating sagot, dinivide ko na agad sa 1,000 para mas mabilis. Pero still lang makukuha yung sagot dito sa sinubstitute nating formula ay data is 128,633.9 Pascal. Ay, kinonvert ko lang agad siya sa Pascal kasi mahaba. Okay, nasundan ba guys? Questions?
Sundan naman, sir.
Okay, thank you. And we'll move on dun naman sa examples na may change in height. Water flows through a pipe at the rate of 0.8 meter cube per second. Ito nga yung figure kanina. If the pressure at point A is 150 kPa, yung point na dito is 100 kPa, find the following. The velocity at point A, yung hanapin natin, yung velocity at point B, and yung pressure at point B. Guys, i-correct ko na lang mamaya yung itong portion na to, yung isang R. Instead, ito yung H dapat to. Kasi ito yung difference in height nila, which is yung equal to 2 meters. So, ang muna natin kukunin is yung velocity at point A. Yun nga, yung nagamit din kanina, Q is equal to area times velocity. And V is equal to Q over A. Or pwede nyo na lang i-direct shift solve sa calculator. So, given naman yung discharge na 0.8 meter cube per second and yung area given is yung radius. So, ang area ng circle given the radius is pi r square. Substituting the equation, 0.08 meter cube per second and yung given radius na since 16 cm yung given, convert it into meters. So, pi times 0.16 square. And the answer is the velocity at point A is equal to 0.9947 meters per second. Okay, let's move required letter B at velocity at point B. Cube per second pi r square and convert it into meters. So we can get pi times 0.3. So the velocity at point B is equal to 3.9789 meters per second. Sino sa inyo ang calculator dyan? Can you double check kung tama naman yung kukuha natin ng point B? Or baka ako yung nagkamali. Baka may mali na itong point B natin. Mali natin yung kukuha natin ng point B. Dun sa pressure at point B. Can anyone solve kung tama yung makukuha pag divide yung 0.8 meter cube per second over yung pi r square? Anyone? Hello guys, meron ba na nakasolve sa inyo? Hello guys, may nakapag-comment ba sa inyo? Kung tama yung nakukuha natin na value. Point 2 na bumilis pa. And since yung head loss naman is na nagdi-decrease ng flow ng fluid, kaya nandito siya sa right side. And other example is, wait lang. Yun nga, it increases the flow and the discharge of fluid. So, computing the output of the pump, kasi will compute for the output of the pump in terms of HP, or kung familiar kayo yung horsepower. And to get the output or the horsepower, we'll use the equation Q times yung gamma. Q is the discharge, gamma times yung head added over 746.
Napatugan.
And yung magiging result niya is horsepower. Okay, other example is the turbine naman. Turbine, may kinaniwan, may idea ba kayo about dun sa turbine? Ang turbine kasi is yung nilalagay dun sa body of water para mag-slow down yung flow ng tubig. So, ang turbine is to lessen the flow of water. Kaya, ang ilalagay natin yung turbine, which is dito siya na portion, kasama niya yung head loss. Kasi pumipigil dun sa pagbilis ng flow ng tubig. Yun nga, it decreases the flow and discharge of fluid. Yun yung contradict nila sa pump and turbine. Pump na pinapabilis niya yung flow ng tubig, nagdadagdag ng other output, while yung head, HE, HE tsaka yung head loss, HE is head extracted, plus yung head loss, yun nga, yung nalilesen ng flow ng tubig, kaya nandito sila sa right side ng equation. So, ganun din yung to compute for the output. In horsepower, ganun din yung same formula sila ng pump kanina. Q times the gamma times yung head extracted over yung 746. Yung 746 ata is, verify ko mamaya kung nasa what, yung conversion ng watts into horsepower or joules into horsepower. Okay, example tayo. Water is to be delivered from a reservoir through a pipe to a lower level and a discharge into the air. Here below. If head loss in the entire system is 11.58, determine the vertical distance between the point of water discharge and the water surface in the reservoir. Okay, kailangan ang hinahanap is the vertical distance between the point of water and the water discharge and the water surface in the reservoir. Ito nga, yung hinahanap niya, yung H. So, kailangan natin kunin yung velocity. Okay, guys. So, ang given discharge is 0.0631. Talagang maumay kayo sa formula na Q is equal to E. Gamit na gamit talaga to. So, ang discharge is given is 0.0631 times yung diameter, yung given. I will just use the pi r square, or you can also use the pi d square over 4. Pero ito na yung ginamit ko, pi r square na lang. Ganun din naman yung makukuha. Times yung velocity. Yung velocity at this point is 3.2137 meters per second. And since walang given na reservoir to, wala tayong makukuhang exact diameter na at point 1 kasi this is the reservoir, we'll just neglect the diameter at this point. And balik ulit tayo dun sa main formula. And yun nga, ang given sa problem is the head loss. So we will use the equation with we will balik tayo dun sa main na formula and idadagdag lang natin yung head loss. And since head loss is nagle-lessen ng flow ng tubig, dito siya sa right side ng main formula. So yung pressure at point 1, since hindi naman siya close na container, this is from a reservoir. Ang pressure at point 1 is the atmospheric pressure, which is equal to 0. And yung velocity at this point, wala kasi dito manggagaling yung tubig, hindi pa naman siya nagpo-flow agad. And yung height the potential energy is the density times GH1, substituting 1000 times 9.81 times yung H. And we will use the bottom part as the reference line. So, transfer tayo sa kabilang part, kabilang side. P2 is equal to 0 kasi discharge into the air. Sabi na naman niya. Open na naman siya. So, the pressure at P2 is equal to 0. So, walang pressure at point 2 kasi it is discharged into the air. This is an open pipe. Plus, yung substituting the other equation, 1/2 times, and yun nga yung density is, the given fluid is the water, so 1000 times yung nakuha natin na velocity at point 2 is 3.2137 square. Plus, yung portion na to kasi is yung ginamit natin na H as reference line. So, mag-0 yung H niya dito banda at point 2. So, pag kahit substitute natin itong equation natin dito, times 0 is 0 pa din yung makukuha. So, i-0 na natin guys. Plus, yung head loss na given na 11.58. And we will get the answer, the height, yung vertical distance between the point of water discharge and the water surface in the reservoir. H is equal to 12.1064 meter. Okay guys, we will use, sabi ko nga kanina, may relationship dun sa mga pressure form, dun sa energy form, saka head form. Kahit saan gamitin mo doon, makuha at makuha mo pa din yung sagot. Let's take the example yung head form kanina. Dun sa head form kanina, ito yung formula niya. P1 is equal to rho g plus V1 square over 2g times H1. And P2 over rho g plus V2 square over 2g plus H2 plus head loss. Okay, substituting, since open nga yung saka nasa reservoir, pressure at point 1 is equal to 0. Yung velocity naman natin is equal to 0 din, plus yung H1, dito na, since yung H2 yung reference line natin, meron yung H1, plus yun nga, discharge into the air, so pressure 2 is equal to 0 din, plus yung given, ay yung na-compute natin na velocity, which is 3.2137 square over 2 times yung gravitational acceleration due to gravity, 2 times 9.81, plus, yun nga, yung ginamit nating reference line yung H2, so 0 din siya, plus yung given na head loss, the entire system is 11.50. You will arrive, ang makuha nating sagot is, ganun din, H is equal to 12.1064 meters. Any questions or clarifications? Or nasundan naman nasundan naman?
Sir, tanong ko lang po, ano po yung unit ng head loss?
Ay, head loss? Ang head loss kasi is nasa meters din.
Sige po.
Sorry, ako nga pala, hindi nakaspecify. Ang head loss, ang unit niya is meters kasi yun yung difference in yung what do you call this one? Kumbaga kung head loss kasi is kung ilan, kumbaga 2 na yung mismong height niya, and since nga pinapabagal niya yung flow, nagkakaroon siya ng difference dun na portion. So kung due to head loss, kung 2 yung nagiging height na niya talaga, lumiliit pa yon into mga 1.95, mga 0.05 yung binababa niya. Basta ganun, head loss nga, nagle-lessen or nag-decrease yung flow. Okay, any other questions? Kaya pa guys, may pump tsaka turbine pa. Okay, another example of head loss. In the figure, if the difference in elevation between A and B is 10 meters, and the pressure at A and B are 150 kPa and 250 kPa respectively. Find the direction of flow and the head loss given the specific gravity of fluid 0.85. Gamitin natin yung kanina, yung last na formula, the head form. PV over rho g plus PV square over 2g plus yung height at B. And it's equal to PA over rho g, A square over 2g plus height at A plus yung head loss. Ang tinatanong is the direction of flow and the head loss. Okay, lang guys. Okay, substituting the equation at point B, 250 kPa over yung rho, yung density, since given walang given, hindi water ang fluid natin. The fluid is unknown fluid pero with a specific gravity of 0.85. 1,000 times yung specific gravity na 0.85 times 9.81. Plus, yung velocity guys is yung, since there is no change in the pipe, walang acceleration na naganap, we can cancel, yung acceleration niya at point A, siya din yung acceleration niya at point B. We can cancel out the velocity, yung velocity niya at point A is yung same as velocity niya at point B. So the velocity, i-cancel out na lang natin, i-cancel natin yung velocity. Plus yung HB, kunin natin yung lower portion niya as the reference line or the datum line. Yung at point B, kaya 0 na lang din, 0 to. And the other side na pressure at point A, 150 ppa, 150,000 times yung density times G, and 1,000 times yung SG na 0.85 times 9.81. Plus, yung, since na-cancel out na nga natin, kasi sabi ko nga, parehas yung velocity at point A is equal to velocity at point B, so we just cancel out din. Kasi kung parehas nga yung velocity, 3 meters per second less 3 meters per second is 0 din yung kakalabasan niya. So, you can just cancel out. So, and yung height at point A, since yung point B nga yung reference line natin, yung height niya is 10 meters. Plus yung head loss. Since head loss yung hinanap natin. And substituting the equation, you can input sa calculator nyo, shift solve or transposing the given values para may separate natin yung numbers sa head dito sa portion na to. We can transpose this part into this part. Ang maging sign symbols na dito pag transpose po dito is less na 150,000, tapos yung portion na to less yung 150,000, less yung 10. Kasi ito transpose nga natin dito sa left side. So the head loss is 1.9926 meters. Can someone recompute kung tama nga yung pag-compute ko ng head loss niya? Hello guys?
Ngamot dun.
Hello, kaya can someone compute again? Kung tama nga yung nasolve ko, mamaya may iban pala. May hindi ako naisali.
Sir, tama lang, sir.
Tama lang po, sir.
Okay, thank you. So, hinga muna tayo guys.